Hi and welcome to another Carpenter tutoring tutorial. I'm Amy and my job is to help you work smarter, not harder. Today we are going to be talking about the ideas behind solving polynomial equations. You may hear questions asking you to find the roots of an equation, to find the zeros of an equation, to solve an equation. Those are all different ways for asking for the same outcome. In order to do this, we have to take an equation and turn it into factored form, and then we use those factors to find the solutions, the roots, or the zeros of that equation. Why there are so many different names for the same thing, I don't know, but it's important to know that they all ask us to do the same task. Let's say that we had started with an equation, we did some work, and we got it down to the factored form of x plus 3 times x minus 5 equals 0. Something that I said in there is actually very important. It's important to remember that these parentheses are representing multiplication. That is a vital piece to why this process works. It's also vitally important that your equation is set equal to 0. You shouldn't be factoring anything before your equation is set equal to 0, so make sure that you double check for that step before you start factoring anything. The idea behind solving polynomial equations comes from the fact that we are multiplying however many factors we have together to come up with an answer of 0. It also hinges on the idea that any number or any number of numbers times 0 ultimately equals 0. What that tells us is if either one of these factors, the x plus 3 or the x minus 5, equals 0, then when I multiply these two together, the entire thing will equal 0. So we use each factor and find the situation when it would equal 0. So I'm interested in when x plus 3 would equal 0, and I'm interested in when x minus 5 would equal 0. From here, we'll use our normal steps to solve for x. So in the green equation, I see that I have to subtract 3 from both sides. That gives me x equals negative 3. In the blue equation, I see that I have to add 5 to both sides. That will give me x equals positive 5. These two values then, negative 3 and 5, are our solutions, or roots, or zeros, whichever name you want to use. That's because if I plug in a value of negative 3 for x, it's going to cause this first term to equal 0, which means the entire equation, when I multiply it together, will equal 0, meaning that this will be true. Additionally, when I plug in a value of 5 for x, it's going to make the second term equal 0. So when I multiply everything together, it keeps this equation true. That's the idea behind making sure everything is set equal to 0, and then taking each of our factors, however many factors we might have, and setting them equal to 0 and solving from there. Now let's say that we had something a little more complicated at the beginning, where we didn't just greatest common factor at some point. Don't forget that this is also one of the factors being multiplied by all of your other factors, creating a product of 0. So if it equals 0 on its own, the whole equation equals 0. That means we have to use that as another factor. And the good news is anytime you have a variable that was taken out as a greatest common factor, its value is just going to be 0. If x squared equals 0, I take the square root of both sides. The square root of 0 is 0, so that tells me x equals 0 is another one of our roots. If you follow this process for any factor that you might have, whether it's a greatest common factor on the outside like this x squared, or a factored expression like the x plus 3, x minus 5, or even something a little more complicated, you'll be good to go and you'll find all of your solutions. Thanks so much for spending part of your day with me. I hope this video was helpful. Let me know in the comments if there are any other general explanations that you'd like, and be sure to check out other videos that go through solving polynomial equations from start to finish if you'd like to see this process in action. And I'll catch you next time.